Earth Science video. Again, this is Norris Teaches Science. Another Earth Science Edition video. We're still talking about lithosphere stuff. I'm Mr. Norris, and today's video is about volcanic landforms. So I can describe the landforms and locations of volcanoes. That's your goal for today. So let's start talking about volcanic landforms. The first volcanic landforms that we're going to talk about are called calderas. They're large depressions in a volcano. You can kind of see that right here. All right. Now, they can form two ways. They can either form from the collapse of the top of a composite volcano after an explosive eruption. So basically, there's an explosive eruption, and then it just collapses in on itself. And the other way, it could be the collapse of the top of a shield volcano after the magma chamber is drained. One thing that can happen is that they can fill with water and become a lake, but I wouldn't swim in that water because it could blow at any point if it's a stratovolcano. Volcanic landform next one is called lava plateaus. It's a wide, flat surface formed when large amount of highly fluid lava flows over an area. You can kind of see that over here in this picture. Usually it forms from something called fissures. They're just openings in the ground where lava can flow. And then you have some intrusive igneous activities. Plutons are what all of them are classified under. They're structures that result from the cooling and hardening of magma at depths. Means it's inside the earth. They're classified according to their shape, size, and relationship to the surrounding rock layers. So the four that we're going to talk about are sills, dikes, lakoths, and batholiths. All right. So sills. This is magma injected along a sedimentary bedding surface, usually parallel to the bedding plane. So I'm going to highlight it right here. This is a sill. All right. It was injected parallel. You can kind of see there's one surface, there's another surface, parallel. Lakoths are magma is intruded between sedimentary layers. It's usually close to the surface, and it's a lens shape. You can see that up here. And then a dike is magma injected into fractures, usually cutting across rock layers. You can see the dike in this picture as well. Then you have a batholith. It's a large intrusive igneous body. It has to have a surface exposure greater than 100 square kilometers. And here it is. It's usually bigger underneath than it is at the surface. Then we have some interplate activities that happen with volcanoes, and we kind of talked about this. This is one of the evidence to plate tectonics. So this stuff happens in the middle of a plate, not at a plate boundary. So you're talking about like hot spots, like the Hawaiian Islands. There's a area of magma that comes up in the surface, and it forms a volcano. And as the plate moves over it, new volcanoes form. And then something called the Ring of Fire. You can kind of see it here. I'm going to highlight it. Ring of Fire. I think of Finding Nemo with Ring of Fire. Shark bait. Ooh ah. But it's an area around the Pacific Ocean. Extreme volcanic activity. It usually shows the Pacific plate border. You can see that there's some in North America. Then you have Aleutian Islands, and you have Japan, and all the other places. I'm not good with geography, so don't ask me to name every place up here. That's what Google's for me. And then plate tectonics and volcanoes, there's a relationship. The plate movement is the mechanism at which mantle rock melts to generate heat. So remember that sometimes some plates go underneath the other. When that plate starts to melt, it creates the magma that then can come up and form the volcanoes. and you get your, volcanoes at different plate boundaries. Just depends on what they are. If you don't remember those, you need to go back and check out the plate boundary video again, because it talks about all the different volcanic island arches and continental volcanic arches and stuff like that. But that plate tectonics is the mechanism of creating a lot of the magma that volcanoes need. And this is a little bit about volcanic structures. I really hope you learned something today. This is Mr. Norris, and he is signing out of this video.